All right, here we go. I neglected to remind you of the rule in 9.2 notes on Thursday, and I'll try to remind you again on Monday about this, but here's another problem from 9.1 which illustrates that rule. The rule says that if this is the rule of intercepted arcs. Okay? So if you have a circle, let's not even bother marking the center, but if we have an intercepted arc, and let me mark the arc too, so there's the arc, all right? That this angle will measure x degrees, then this angle will be x degrees divided by 2. Or you can think of it as, okay, the interior intercepted arc is x, and then the exterior one is twice x. All right? So that's kind of a relationship between the two. For example, in this particular problem here, number 7, it says find the measure of angle A, and we look at the diagram, and there's A. A intercepts arc BC. See how it kind of cuts off that arc? BC is captured inside it. So then the measure of angle A will be half of 80, which is 40. Now, if we look at measure of angle D, this comes up later in another problem. D's up here. And notice it captures the same arc. So again, 80 divided by 2 is still 40. 40 degrees. Yeah? And I think this applies to problem both 15 and 16, which we kind of talked about in class. Right? Again, here we have an angle which measures 45 degrees. Therefore, the arc is 90. So we could even say I could figure out the coordinates of J. They didn't ask for this, but I know that it's 2 over. And then if I go up from 6, I get, from 1, I get 2, 7. Again, because this distance here is a radius, and I know that distance is 6, this has to be 6. All right? Okay, hopefully that helps and clarifies that missing rule that I did not talk about on Friday.